Now student, we are taking the combination of capacitor, that is series and parallel. So series you have done means like hand to hand they are standing, like you have done for series combination also of resistances in the previous classes. The same way we are having the capacitors are connected in series, means one plate of the second one is connected to the second plate of the first one, and so on. Net potential is V. Now the dielectrics can be same and the different also. Accordingly, values of C1, C2 and C3 can be different. So that's why we are saying the values of potentials across the plates of three capacitors will be different. So we are having V is V1 plus V2 plus V3. Now in series combination, say whatever charge is coming from the battery, that will be here, and that positive will induce a negative here and the positive on the outer plate. That will come to the second plate. Same thing will happen for the second capacitor and the third one, and finally whatever opposite charge is there, that will come to the battery, and that way the circuit will be complete. So we can say in series combination, the charge on the plate of capacitor is same for all the capacitors. So we have Q upon C, value of V we are putting. So is Q upon C1 plus Q upon C2 plus Q upon C3, or we get 1 upon C is 1 upon C1 plus 1 upon C2 plus 1 upon C3, where C is net capacitance. Similarly, when we are putting it in parallel, then in parallel potential difference remains the same, and amount of charge will depend upon the value of capacitors of the individual capacitor. So that way we can say that total charge from the battery will remain the same, and that is Q is Q1 plus Q2 plus Q3. Now Q is C into V. So where C is net capacitance, so we are having C into V is C1V plus C2V plus C3V, because in parallel the voltage remains the same. So we are having C is C1 plus C2 plus 3. So one more thing you have to keep in mind, you can have a number of questions based on series and parallel combination, but don't go on the diagram only. Because if you are having these two capacitors C1 and C2, and question is saying, say V they have not given, but they are saying only this much diagram is given, means C1 and C2 are connected like this, and they are saying C1 is charged and C2 is uncharged. So when one charged and one uncharged capacitors are connected, then charge will start flowing from one to another till they acquire the same potential, and that is the condition of parallel combination. So keep in mind that whenever one charged and one uncharged capacitors are connected, the combination is always parallel. And the last heading of the chapter, energy stored in a capacitor, when we are transferring the charge, so we have to do the work, and work done is given by, we can say, the potential difference between the points into amount of charge. Now here between the plates, whatever individual plate you are having, the charge is continuously increasing. So we can say if we are transferring very small amount of charge, then for that we can take V as constant. So small work done in transferring the charge dq from one plate to another, when the potential difference is V, will be dw is V dq. So total work done is integral of this. Now put the value of V upon V, that is Q upon C, and on integration we get half CV square, or we can say Q square upon 2C. Now, one thing you have to keep in mind, in numericals, you have to calculate the work done. So, for comparing for series combination, charge is constant. So, we always apply the formula Q square upon 2C. And for parallel, for comparing, V is constant, we apply half CV square. And last, energy density. Energy density for parallel plate capacitor, so its whole derivation can be there for 3 marks. So, energy density, as the name itself says, means total energy per unit volume. Now, total energy in this case is half CV square. Now for parallel plate capacitor, C is epsilon naught A upon D in absence of dielectric medium, and V is given by E into D. If you substitute all the values, then after solving we get half epsilon naught into E square. And we can calculate it in terms of surface charge density also, half sigma square upon epsilon naught. Now in the next video, means tomorrow, we will discuss the questions based on capacitors and dielectric. Thanks and take care.